Hi, how's it going? Apologies if any of the outside noise is getting in. It's a hot day, I just had to open a window. I think it's probably time for me to look at skeletal animation. I've put it off long enough. I've covered elements of it. I've done approximations of it. I think it's time for me to sit down and do it for real. The way I'm going to structure this series, the reason I'm making a series for this is skeletal animation is a reasonably tricky topic, and I could make one short video where I try to impress everyone with how quote-unquote cool and smart I am, but I would much rather explain it properly. I feel there's a lack of clear tutorials on the topic. As motivation, picture the Doom Eternal Marauder. I say this a lot. When the Doom Eternal Marauder came out, people found it really challenging. But when you know the skills and you understand the principles, the challenge becomes fun. So my goal with this series is to make skeletal animation fun. What I've done, there's a lot of stages, is I've tried to roughly break this down, and as I go along, if any of these stages become too unwieldy, I will break them down into further sub-steps. But I've got my little plan out here. So these are the stages I'm going to go with. To start with, I'm going to be using GLTF, which is based around JSON. So I'm going to read JSON files in C++. Then the next step is GLTF models also include binary files, which are just raw bytes of data. So I'm going to go through how we open up binary files, read them, and then given an offset, a format, and like an element count or something, extract data. Basically, read the raw binary and then extract various formats of data from it. After we've done that, I'm going to bring it all together and display a static model from a GLTF file. That is a model with no animation applied. So the first stage is really just understanding the GLTF format. Once we understand the GLTF model format, the next goal will be basically geometric. So the next stage is I want to be able to rotate a mesh around an arbitrary point. I'll make a little demo, for instance, load in a triangle or any other mesh, click somewhere on that mesh to drop a pin on it, and then use some arrows to rotate around that pin. Then, once we've done that, skeletal animation deals with hierarchical transformations, hierarchical coordinate spaces. So I'm going to have a look at the concepts behind that, and I'm going to implement a simple skeletal animation just with hard-coded data on the CPU. Just get that going, like a pair of legs walking or something like that. Once we've understood the concept, the mathematical concepts behind skeletal animation, and once we've understood the GLTF model format, the next stage will be to load in an animated GLTF model and skin it on the CPU. That is, calculate all of the transformations that we need to do on the CPU and do that. And then the final stage will be to do the whole thing on the GPU. With that said, that's what I'll be doing in this series. So I hope you get some value out of this and enjoy it. No more to say, so on with the show. All right, so here we are, ready to go. I've got this folder here, and if you open the linked repo, you'll see something very similar to this. Now, I decided to go with Visual Studio, but that's not for any particular reason. Actually, it is. It's because my Windows computer, the debugger just wasn't working. I was trying CMake with Visual Studio Code. I wanted to have the debugger. So anyway, if we open this up, it is pretty bare bones. It's just your normal hello world, basically. But in addition to that, we have two files. We have mycube binary and mycube GLTF. What I did is I opened up Blender, I exported the default cube, that's it. So if I look at mycube.gltf, it is a JSON file, pretty much. And so we're going to need to read that. Okay, so the goals are, first up, open this JSON file just as a standard text file, print its contents, just to check that the file IO stuff is all working. And then the second step is to do the same thing in JSON and get some meaning out of this stuff. Let's do the standard file stuff first. So I'm going to need other ways to do it. I'm going to do file streams, and let me just open this up. So yeah, we're opening up the mycubegltf file inside the source folder, and now I'm just going to look through it one line at a time. I guess we need string stream for that. So we'll just print that line. And then go ahead and close the file. Let's run that and see what happens. Nice. We've looked through the file, we're printing it out. So now what I'm going to do is I'm going to read this JSON style. And in order to do that, we're going to need a library. I'll just bring this up. This is the JSON CPP library. I don't know who Jason is, but it seems pretty popular in the data science field. So what I'm going to do is I'm going to copy that one and get your hat on, because we're going to do some hacking. So I'm just going to open up the terminal, clone that. So if I look in here, we have this JSON, but this is just the source code. Like, hey, again, apologies for the cicada noises. Hey, has anyone watched, what is it, Neon Genesis Evangelion? That show's full of cicada noises. People love it. There's two ways to do this, the easy way and the hard way. I'm going to do it the easy way. The hard way is basically to run CMake on this folder, and it'll build things. I found it was a little janky. So here's a slightly better way to do it. The easy way. In the folder, the stuff that we downloaded, there's this amalgamate Python script. If we run it, what it does is it fetches all the relevant source and throws it into basically a minimal one source file, two headers, I think. So this has all been written to the dist folder. So I'll close this down. We'll go to the dist folder, which is now created. And inside here, there's this JSON, which includes the headers and this JSON source file. So I'm going to grab both of those. I'm going to go back. I'm going to get rid of those old headers, put in these amalgamated ones, and the JSON CPP, I'll put it into source. So that should be good to go. Now I'll go back to the project and just reconfigure it. First up, for the source folder, I will add an existing item. That's the JSON CPP. And I'm also going to configure the include directories. So I'll just go down to properties on the project. I'll go to the C++ directories, include, and I'll look inside the dependencies folder. Okay, so I should now be able to include JSON. Great. By the way, I'll get rid of this. We're done. We entered, open the text file. So now I'm going to open this again, but I'm not going to interpret it as pure text. I'm going to interpret it as binary. So there's an option I can input here. That's input output stream binary. And now instead of reading to a line, I'm going to read what's called a JSON value. So if we were to look at this file, it's a dictionary basically, but this is sort of like a hierarchical tree. So this whole thing, because it's enclosed in these braces, counts as a JSON value. But then this thing, because it encloses a set of braces, also counts as a JSON value. And this is a JSON value with children, because we have this generator and version, just like the encompassing scope is a JSON value with children, asset, scene, scenes, and so on. But then when we get to this point, for instance, this thing itself would be a JSON value with a single direct, like it's an external node of the tree, basically. So hopefully that makes sense. And this is sort of what we'll be investigating. So I'll just put that off to the side. But for now, what I want to do is grab everything. So now I'm just going to investigate this a little bit, run it in debug mode, check that it worked. So at this point we're paused. I'm going to add a watch. Great. So we have this JSON value currently with nothing in it. Let me step over. and we've got some stuff, and it is not great, not the most readable thing, but I do think it's good to be a little comfortable with the debugger. Now I'm going to get a description of the asset, let's say. So if we want to get a child of an element, we can do it like this. So imagine that this object here is the asset. We can then grab its generator and version. And let's say I want to print those out to the console. No problem at all. What I can do is, so I have asset, and asset has these children, generator and version. So I access the child generator, and then I use the as string function to convert that to a string, and I can do the same with the version. Check that we're correct. Well, yeah, let's use the debugger. Why not? So as you can see, we have here the asset. There it is. We haven't filled it in yet. We also have the generator and version. As I step along, the asset is filled up. The version, generator, sorry. Yep, that matches what I can see here. And same with the version. Awesome. So what I could then do is print this out to the console. Perfect, and we can see that we're getting what we expect. Okay, so this has been an example of reading a, is it hierarchical or, it must be hierarchical, right? That's just a really awkward word to say for some reason. Okay, reading a hierarchical JSON data structure. The next thing is, how do we deal with, get the default scene number. If I want to get scene, which is this thing here on line 6, that's the index of the default scene. I'm going to go to the file, which is parsed contents. I'm going to access its scene child, and I'm going to get that to an integer. Great, and as we can see here, that default scene index is 0, just as we can see in the file. Excellent. So then the question is, right, well, that's pretty much almost all it is. The only other thing we have is lists of objects. You can see here, for instance, scenes. We only have one scene. This is its description, but it would be good to be able to deal with lists of objects. So let me actually play around with this a little bit. Hopefully that didn't break it. I'm just going to make a duplicate scene just to test. So what I want to do is I want to get, I want to get the number of things here. So I'll go scenes, which again is this list here, and then I'm going to call the size function on it. Okay, so because I created a duplicate, I'm expecting to see file has 2 scenes. Let's test that. Nice. There we can see file has 2 scenes. And just so that it's not a fluke, we can go ahead and remove that duplicate entry. File has 1 scenes. That's great. And we can access these scenes just the same way you would any element of an array. So if we want to get the 0 index child, we'd go parsed contents scenes 0, and that would be this one here. If we had more, we could keep using that square bracket accessor to get more children. So there we have it. That has been a little brief overview of reading GLTF files in C++. Hope you enjoyed that, and I hope to see you again soon. Bye!